Hi, this is Jayendra Khatod and I'm here to chart the best fit on Azure. In this video series, we pick up an Azure service and try to deep dive into its pricing and sizing aspects so that you can create the most optimized consumption plan for your customers. Joining me today is our guest speaker, Bhaskar. Hey Bhaskar, why don't you tell our viewers what do you do here at Microsoft India and which Azure service are you going to talk to us about today?
Thank you, Jaindra, for giving me the opportunity. Let me introduce myself. I am Bhaskar, working as a cloud solution architect at GPS India Microsoft. I primarily work with Microsoft partners and help them in data and AI solution areas. Today, we are going to discuss about the Azure Synapse Analytics, which is one of the flagship service of Microsoft. Let us try and understand what are the key things that you should be looking at for the right sizing when choosing the best fit for the Azure Synapse Analytics for based on your customer workloads. As you see here, these are the key resources that you should be looking at or which are built when you provision the Azure Synapse Analytics. Let us try and understand what each service or which resource looks like. We have a dedicated SQL pool, which is nothing but the data warehousing workloads that leverage a scale out architecture to distribute the processing of your data across multiple nodes. Here, compute is decoupled from storage, which allows you to scale compute independently of the data or storage. Here, you are charged for the number of DWs that you have provisioned and the number of hours they are running. When I say DWU, it is nothing but data warehouse unit, which is a combination of compute, memory, and data IO required to process your data. We have a storage, which is again associated with the dedicated pools or dedicated SQL pools, which includes the size of your data warehouse and the backups. You are charged for the data that you are storing on the disks. So it is charged based on the number of terabytes of data that you are storing. Next, we have a serverless SQL pool, which allows us to query data using T-SQL, which is stored in ADLS. And you are charged by the size of the data process, not based on any resources allocated or the compute allocated. You would be charged based on the size of the data that you are querying, and here queries will incur minimum charge of 10 MB, and each query will be rounded up to nearest 1 MB of data processed. Next, we have Apache Spark Pool. Apache Spark Pool is used to perform your big data processing using Spark workloads. Either it could be data engineering, data prep, or any machine learning workloads. And here you are charged based on the number of instances provisioned and number of hours those machines are running. And next we have a data integration. Data integration is nothing but the data pipelines orchestrating the ETL workflows by activity runs. You are charged based on the activity runs, data movement, and data flow weaker hours which you are using for applying the transformations. We'll discuss on how to right size the data integration in our next video along with Azure Data Factory, and we would also share the links in the descriptions below. This is the pricing calculator, and if you go to analytics, and there you can see the Azure Synapse Analytics. In the Azure Synapse Analytics, where you have a data dedicated SQL pools, where you will be choosing the number of DWs that you would like to provision, and you have a storage, serverless SQL pool, Apache Spark pool, and then we have data integration, where we would be discussing in our next video along with Azure Data Factory. So before I choose the DWs, let's understand what are the key things that you should be aware when choosing the DWs. So you can choose starting from 100 data warehouse units, and it can vary up to 30,000 data warehouse units. Based on the performance level, the compute nodes, distributions per compute node, and memory would vary based on the performance level that you have chosen. For example, I have DW 100. I have chosen 100 units. So I will get one compute node where I have one compute node will manage all the 60 distributions of the data warehouse workloads, and you will have 60 GB of memory that would be allocated to your workload, and you can have maximum 4 concurrent queries here. So when I say 4 concurrent queries, there can be 4 different queries that can run parallelly on your data warehouse workloads. And here we have a active connections. Active connections uh, at any time or irrespective of the service level, it will have 1024 active connections. So when I say active connections, the number of connection that can be open to your data warehouse. So the maximum is 1024, and if there is any connections beyond 1024, then you might get an error saying that the connection is failed. But at any based on the service level, you would be getting the number of concurrent queries here. Memory and concurrency limits for dedicated SQL pool in Azure Synapse Analytics, which will give you the details on each service level, how many compute nodes are distribution allocated, and the maximum concurrency that you would get based on the service levels. So using this, I have summarized that table. Now we know the memory and concurrency limits offered by each service level. Let's try and understand a couple of more resources that we should provision for Synapse dedicated pool, like storage. So we should understand what is the size of the data warehouse you are envisioning and what is the size of actively used data in your data warehouse. These are required to save the cost on storage associated with the dedicated pools. Let's say, for example, I have 100 terabytes of raw data. I may not intend to move entire data to Azure Synapse dedicated pools. I may archive or purge the unused data or unwanted data so that I can save the cost on Synapse dedicated pools. And we should understand what is the maximum peak time concurrent users and what is the maximum off peak time concurrent users. These are required because, say for example, if you have a payroll system where at the month end, most of your users will log into your system and try to access the payslip reports. And there could be another season where it's not a month. In between the month, many of the users may not be logging into your payroll system and may not be using your data warehouse workloads, where you can drastically reduce your DW unit so that you can save the cost. So there are scale up and scale down options that are available in Synapse, which you can use to reduce this cost of DWS. And we should understand what is the frequency of and size of the delta changes. These are required. Say for example, we need to understand whether I am running a nightly jobs or whether I need to run hourly jobs, and what would be the size of the delta changes that I am loading into my data warehouse. These are required, like typically in a native job or a batch jobs, you might need a huge processing power, which could help to process your data faster. In those scenarios, you could scale up your Synapse Analytics to provision more DWs and complete the job within the timelines so that you can save the cost. And we should understand whether we need our workloads to run 24 bar 7, or is it only at a certain period of time you need those workloads. So all these factors matter when we are provisioning the Azure SQL Synapse dedicated pools. Let us consider a hypothetical example which has a requirement to provision a data warehouse with 50 terabytes of raw data with annual growth of 15% of the data. Here I'm assuming the data size would come down to 20 terabytes after purging or archiving the unused data and the historical data, and also applying the clustered column store indexes, which would again compress the data by 5x. The data would come down to 20 terabytes is the assumption that I have made here. And we have consider we have a requirement at the maximum number of concurrent queries at peak time is 25, and at off peak time we have a 10 parallel queries need to be run on the data warehouse. Considering these parameters, let us go back to the table which we referred earlier. So for off peak time, we have a requirement of 10 concurrent queries or parallel queries running on our data warehouse, which would based on this table, it would have a requirement of 300 data warehouse units. And at a peak time, we have a requirement of 25 concurrent queries. So here I would choose 1000 DW units for provisioning the dedicated pools. So that's so the based on the maximum number of concurrent users, we have chosen DW 1000 DW for a peak time, and DW 300 for off peak time. And consider we have a requirement of serverless pool as well, where we process daily 1 terabyte of data, and monthly we would process 30 terabyte of data. So assuming we also have a Apache Spark pool where we run a batch jobs daily for 3 hours. So I've considered those 3 hours here, and I'm starting with the two medium instances to process my Spark workloads. Considering we have a auto scale enabled, which gives us the flexibility where it can go or it can auto scale starting from 2 to maximum number of nodes that you are specified in when while you are provisioning the Spark pool. So it will auto scale or auto add the compute nodes as per the requirement. And it also has the option of auto disable. Say for example, if your instance are inactive for some time which you specified, or the minimum time which you have specified while provisioning, so based on that time, if it is inactive, it would automatically disable the instances, so you are not charged for those many hours. And so considering daily we are running Spark job for 3 hours, and for a month it would come up to 90 hours. So let's go to the Synapse calculator here. So if you go to analytics, and you can click on Azure Synapse Analytics, which will add the Azure Synapse Analytics pricing here, where we can choose the region where we want to provision the Synapse Analytics and the compute that you want to use. Here we have a dedicated SQL pool where you need to provision the number of DWs that you want. So before selecting this, let's consider a couple of scenarios which would give us an idea how we can optimize the cost when we are choosing the DWs. If you see here scenario 1, where we have a requirement of running the workloads 24/7 into 365 days. So if I consider 24/7 for a month, it would come up to 730 hours. So I would run 730 hours, and in this case, if I go with the reserve instance, the cost would be drastically saved by approximately 65% of your cost would be saved when I go with the 3-year reserved instance. And similarly, if I have considered a second scenario where we have a workloads running only 12 hours in a day, and we don't need to run on weekends. So considering we have 4 weeks in a month and 5 days in a working days in a week, so we are running 12 hours, so it would come up to 240 hours. So using this way, you can the pause and resume feature, you can save the cost of DWs. And we have the third scenario where we need to run 24/7, but we have a requirement where I don't need the maximum DWs to be provisioned all the time. Only when I'm running the batch jobs or batch jobs, I might need a better processing power to complete my batch workloads within the timelines. Say I'm running 3 hours a day where I need a more DW capabilities capacity. So I'm considering that I need 90 hours for 1000 DWs and 21 hours in a day going to 30 with 300 DWs. So using this way, you can save the where you can use the scale out and scale up and scale down feature to reduce the cost here. Let's go to the cost calculator here, Synapse pricing. So here, so in the first scenario, we considered 1000 DWs running for 730 hours. If I go with the pay as you go, you would be charged 11,023 dollars. If I go with the reserved instance, that would come down drastically to 3,858 dollars 05 cents. So if I have if I consider the second scenario where I have to run only 240 hours with the pay as if I go with the pay as you go. So if I run this, so the cost would still come down to 3,624. So this is how you can save the cost when provisioning the DWs. Or if I consider the third scenario where I have a requirement to provision 1000 DWs at peak hours, which would run for 90 hours, and that is the cost of this. And let's add another Synapse Analytics here so that I can add for the remaining 21 hours of a day. So here, if I consider 300 DWs, and here I'll consider 640 hours. Since I've considered 90 hours would be, we will be running with 1000 DWs, and this is the cost, total cost for the DWs for 21 hours into 30 days. So which is like, so you can choose on this number of DWs and you can scale up or scale down based on your requirement. Let's go with other options here. Let me consider I would go with the 1000 DWs and running uh, and using the reserved instance. I would have monthly cost of 3,858, and I'm as per my assumptions, the data would raw data size would come down to 20 terabytes. I would provision that, and here I can provision a geo redundant disaster recovery scenario where if entire region goes down, you can use the geo backups to restore your service. So if you don't want, you can uh, turn off this so that you're not charged for the geo backups. And here, as per our analysis, so for a month I would use 30 terabytes of data for data processing using Synapse serverless pools. Considering that this is the cost that would be charged for me. As we considered, we would go with the Synapse Spark pool with two medium instances of 8 vCores and 64 GB, and which would run for 90 hours. I'm adding this. So this would come down to $182. So this is how you can calculate the or optimize the cost by selecting the right SKUs based on your workloads.
Well, thank you so much, Bhaskar, for joining us in this episode of Chart the Best Fit on Azure and helping our viewers on how to create the most optimized consumption plan when it comes to Azure Synapse Analytics.
Thank you, Jaindra. Pleasure is mine.
And that's about it for this episode, folks. Until next time, keep learning.